This is a brief overview of statistics as they relate to evidence-based practice and nursing. Now we're going to go over one specific element that can be challenging to understand, and that is statistical tests. This is often a difficult topic. Dare we say some may or may not find it boring. However, we hope that your reading and this video will make statistical concepts a little less intimidating and a little more easy to apply when you're reading research. So you may look at this module and think, statistics, how can I get around learning this? How can I just do the assignments and move on? However, there's a reason you actually need to understand some basic statistical terms and concepts. Now, many nurses are intimidated by statistics or maybe just uninterested. We became nurses because we want to take care of patients, not look at numbers all day. However, all quantitative research will include some sort of statistical information. And thus, a BSN prepared nurse who's expected to be able to read research, understand research, and determine when and how results of high-quality studies can be applied, you can't do this without understanding that pesky data analysis and results section that involve statistical information. Now, not all studies are well executed. Not all authors interpret their results correctly. Maybe some authors make pretty lofty claims based on some pretty weak results. And if you can't understand the statistical results of a study, you might fall for these false conclusions. Also, if you can't understand statistics and basic statistical concepts, you'll be unable to communicate and collaborate and elevate your practice and your potential with your health professional colleagues. So as nurses, we can't just leave the high-level stuff or the hard stuff up to somebody else. This is a mindset that is really threaded throughout nursing. If it's challenging, if it's intimidating, we need to take the time to learn about it, understand it, and see how it might be useful to us. All right, so let's take a step back here for a minute. If we want to know when and how statistics come into play, we need to quickly review the research process. So let's say you want to conduct a study, and let's say you want to do quantitative research. Now, how does this happen again? Well, briefly, it might look like this. First, you come up with what you want to study, and you develop a research question, or two or three. Then you write up a proposal about how you want to do this study, and you send it to the institutional review board to get permission to conduct this study and make sure what you're doing is ethical. Then next, once you get approval, you can start to look for people to participate in your study. Maybe you'll send out flyers or you'll create online ads. And then eventually, you'll get your sample. Let's say you get 150 people that have agreed to participate in your study. And then depending on the type of study you plan to do, you collect data. So what does that look like? Well, in some cases, you're going to collect data multiple times. For example, taking everybody's blood pressure at baseline, so at the very beginning of the study, and then maybe after meditating, and then maybe 2 hours later. Or maybe you're doing surveys and you collect survey data that creates a final score or a tally. Either way, data collection in quantitative research involves getting the information that you need. And a lot of times it has to do with numbers. Not always, but it does sometimes. And numbers, for instance, like blood pressure, or maybe numbers like stress level, or numbers like demographics. For instance, the percentage of people who take blood pressure medication, or ethnicity. Lots of numbers. So as you may have guessed, we didn't really use statistics yet, not to collect data or anything else. To collect data, we used a blood pressure cuff, or a paper and a pencil. We used those things to get data or collect data. Now we use statistics now that we want to make sense of those numbers or the data that we now have. So let's be clear here. Statistics comes into play during the data analysis phase of research. We want to analyze these numbers in a meaningful way. Does blood pressure go up or down after meditating? Did people who take blood pressure medications benefit more from meditating than those who weren't on blood pressure medications? Or was there no difference, or was it the opposite? So these are the kinds of questions we start to put on all of that data that we've just collected, and we use statistics to make sense of all of that data. And then the last phase in the research process is usually taking those answers to those questions, the results of those statistical tests, and making some claims or some conclusions about what our study does or does not suggest. So on a side note, we don't say that a study proves anything. They support a hypothesis or they suggest something. So since we're talking about statistics, let's move back up to the data analysis phase. This is that discovery phase, and frankly, the really exciting part of research. What have we found? What does this big pile of data mean? What new information did we just uncover? Now, in order to make sense of and really interpret all of those numbers that we have to use the right test for the right type of data. So what do I mean by this? Well, for instance, do I want to see if my meditation intervention caused blood pressure to go down? Do I want to see if certain people in the study were more likely to have a higher blood pressure at baseline? Or maybe I had a placebo group in this study. So do I want to see if fake meditating, like maybe sitting in a room watching TV, has the same effect on blood pressure as my real meditation intervention? Or what if I had 4 groups in my study? One is doing my meditation intervention, another group is watching TV, another group is taking a nap, and another group is maybe listening to music. What if I want to see now the differences in blood pressure in each of those 4 groups? And then what if I wanted to see if men versus women responded differently to the meditation intervention? So you can see I can ask so many different types of questions about the same group of people and the same data set or the group of data that we've collected. And there is a very big, wide world of possible ways to look at data and different questions I can ask about that same group of data. There are also lots of different types of data. You may recall hearing about categorical variables or continuous variables. So maybe we're looking at numbers, or maybe we're looking at colors or ethnicity, or maybe we're looking at weight. So all of this can get very complex very fast. Thus, statistics, as you probably know, is a specialty all on its own. And this is why nurse scientists are often very grateful for statisticians who can help us with some of these really, really complex studies. Now, the key thing to understand here is you have to match the data that you have and the questions that you're asking about that data with the right type of test. So think about it this way. I might have questions about the sex of my participants, for which there are really only 2 options for my study. And there's not really a direction to this data. Females are not greater than males and vice versa. Or I might have a question about how much blood pressure changed from before doing meditation to after doing meditation. Now, we really have unlimited options with blood pressure in terms of how much it can go up or down. So I need a statistical test that can take into account something that isn't hierarchical, like a gender, and something that is hierarchical, like a blood pressure. So I keep saying that there are lots of statistical tests and that you have to match the data we have and the questions we're asking. So what are these tests and how do they work? Well, fortunately, during our time, computers, more often than not, are calculating these tests for us. So we're not doing this on pen and paper anymore, thank goodness. Saving a lot of time doing that. And researchers will download computer programs like SPSS or something called Stata and input all of their data from their study into that program. So for instance, all of those different blood pressures from before and during and after their intervention, maybe the gender, maybe all the demographics, they'll input all that data into these computer programs. And then when it's time to run a test on their data, they essentially think of the question that they're going to ask, and they click on the type of test that they want to run and select which data they want to run it with. And there's a lot more clicks that we do, so it's a little more complex than that. But in a sense, we tell the computer program what we want. And it applies mathematical equations related to that specific test to the data that we want. So when we want to run a statistical test, along with the type of data, remember our example of genders versus blood pressures, we also have to take into consideration the sample we have in the study we're doing, the people that we've recruited to participate in our study. This is where concepts of parametric and non-parametric come into play. So if we think about a study on the effects of weightlifting on the speed somebody can run 100 meters, maybe I want to recruit participants from the state of Arizona, and I want to recruit participants that represent every adult in the state of Arizona. Pretty hard to do, right? But I can't include everybody in the state of Arizona. I can only include a sample. So I want my sample to be representative of the population, meaning I want most people in my sample to be about average runners, the average runner, not super fast, not super slow. But I do want to include a few people who are really fast and a few people who are really, really slow. So I want to have this quote unquote normally distributed sample. I want a nice sample that represents the actual population of the average adult, how fast they can run. And as it turns out, I do my study. I have each of my participants, I've got all my participants in my study, and I have them run 100 meters. And I find out that everyone is actually really, really fast. The majority of my sample has a 100-meter dash time of 15 seconds. And maybe the rest of my sample is kind of scattered all over the place, but the majority is really fast. well, shoot, I no longer have a bell curve. I wanted to have some slow people, some fast people, but mostly average speed people, kind of like what happens in real life. What I actually wanted was a normally distributed sample looking like a bell curve, but what I actually got was a skewed sample looking almost like a squashed bell curve, where the majority is kind of leaned up against the side of very, very fast times. So one thing to remember about statistical tests is that we have to consider this distribution of our sample. Did we get a nice bell curve of a sample, or is it skewed? So as you might expect, even more different tests can be used for normally distributed samples. These are called parametric tests. And other statistical tests are used for skewed or asymmetrically distributed samples, and these are called non-parametric tests. So let's look at some actual examples of specific statistical tests. Now, first we have a test called chi-square. And this test can only be used for ordinal or nominal data, so things like gender, ethnicity, or maybe nursing specialty. We can't use a chi-square test for continuous variables like height, weight, temperature, etc. Things that are going to increase and that can be measured on a scale. If we tried to do that, it simply won't work. SPSS will send us an error message saying you can't run this test. Now, chi-square tests are used for non-parametric data. Remember, that means that the sample in our study does not look like a bell curve. So an example of when it would be appropriate to use this type of test could be if I wanted to know if a nurse's gender and the nursing specialty they worked in, for instance, emergency department, ICU, pediatrics, oncology, psych, mental health, I want to know if gender and nursing specialty are related. Or is there no meaningful relationship between gender and where nurses end up working? So I could collect a bunch of data from nurses, have them provide their gender and nursing specialty, plug all of that information into my SPSS or into my Stata program, run a chi-square test, and get data back from my computer program telling me whether or not any relationship between gender and a nursing specialty was related or if it just happened by chance. So the next test is ANOVA, also known as analysis of variance. And this test cannot be used for those categorical variables like gender. Rather, we use ANOVA to test continuous variables. So now we have questions about height and weight and blood pressure and temperature, so think numbers. We're also comparing more than two groups of people, or we've measured a variable like blood pressure more than 2 times. We basically want to know, do these different groups of people have different blood pressures, significantly, statistically different blood pressures? So for example, let's say I have 4 different groups of people. One group meditated for 10 minutes, one group watched TV for 10 minutes, one took a 10-minute nap, and one group listened to classical music for 10 minutes. I now have a whole bunch of blood pressures, a whole bunch of data to work with, and I can divide it into 4 groups, 4 of those each groups. With ANOVA, I can ask the question, did the blood pressure for participants in each group vary significantly? So here are quite a few more statistical tests that exist for different types of questions, different types of data, parametric versus non-parametric. And much of the time, the test is named after the mathematician who discovered it. You can see why our goal is not for you to be able to define every single one of these statistical tests. We really just want you to recognize that many, many, many statistical tests exist out there. And you'll find that certain tests, kind of like some of the ones we've already discussed, are much more common than others. However, when you're faced with an unfamiliar test or you're unsure if the researchers match their data and questions and distribution of the sample to the right test, you can simply look up the test they reportedly used and determine if it was appropriate for the question and the data that they have. So that concludes this brief overview of statistical tests. Just keep in mind this is scratching the surface of the surface. We haven't gone into a lot of the statistical information that you need to understand, but this is often one of those difficult points for students to really wrap their heads around. So make sure that you've done your reading and that you have a clear understanding of other statistical concepts that are in this module.